AP Calculus BC, Unit 7 Day 9, Part B, office hours. So this is a quick worksheet to give you some extra practice with some exponentials and some fundamental theorem of calculus part 2. So if you haven't tried these yet, just as a reminder, fundamental theorem of calculus part 2, I'm going to just write it up here at the top. So fundamental theorem of calculus part 2. And fundamental theorem of calculus part 1 says if you integrate a derivative, you get the original function. And if you have limits, a to b, then you plug in the limits. So essentially, fundamental theorem of calculus part 1 says integrals undo derivatives. Part 2 says derivatives undo integrals. So if you have an integral and you take the derivative of it, now there might be some limits here. These essentially cancel each other out. You plug the limits in, top first minus bottom second, but there's one little thing you got to remember. You have to multiply by the derivative of what you plugged inside. It's a chain rule issue. You have to multiply by the derivative of what you plugged inside. So that's not a formula to remember. It's more just the steps to remember, but that's fundamental theorem of calculus part 2. So as an example, I don't know, we could, like on this one here, you say, okay, these cancel each other out. Then these are going to go inside everywhere you see a t. So it's going to be e to the 2x plus 2 times 2x. I always put them in parentheses. Minus, you're going to plug 0 in, e to the 0 plus 2 times 0, which is not 0 on its own. This is actually 1. But then the thing you have to remember is that what you plugged in, which might show up multiple places, you take the derivative of once. It's a chain rule. Because the derivative, undoing the integral, just that's all it took care of. These limits had not been considered yet. Now the derivative of 0, or any number, is 0. So your final answer would be 2e to the 2x plus 8x. So that's how you do it. Now, stop the video if you haven't tried these other problems and try them yourself, and then you can check your answers and then go over them with me. Okay, assuming you guys have tried the problems, these are the answers. Number 1 is B, 2 is E, 3 is C, 4 is B, 5 is D, 7 is C, and 6 is E. So check your answers if you haven't already. And let's try these problems out. So this one, they do each other, but then you have to plug 0 in first, minus, then you got to plug x in, 1 over 1 plus x squared. And then you got to multiply by the derivative of 0 is 0. Derivative of x is 1. And so then your final answer is 1 over 1 plus x squared. 1 over 1 plus x squared. That's the same thing as that. Okay, we did number 2 together. Number 3, derivative of the integral. Okay, so here, and then we plug this in for the t. So this is, I leave a little room here. Sine of parentheses x cubed squared minus sine of parentheses x squared, because I want to really emphasize what got plugged in. That's the only thing you should be taking the derivative. It shouldn't be x is 6 and write 6x to the 5th. Just the x cubed. Everything else has been taken care of. So this is 3x squared. Derivative of x here is 1. So your final answer is 3x squared sine x to the 6th minus sine x squared. Clean things up. So 3x squared sine x is 6 minus. So that's going to be C. Next one. So these are fast problems. I mean, you guys should like these. Now, this next one, you might be thinking, oh, I got to do the same thing. This is actually FTC part 1. This is FTC part 1. So derivatives undo integrals. So then this would be the antiderivative. And then you would plug the limits in. So 4 squared plus 2 times 4 minus 1 minus 3 times 2 squared plus 2 times 2 minus 1. So 16, that's 48 plus 8 minus 1 minus 12 plus 4 minus 1. 56, 55. This is 16, that's 15. So the final answer is 40. So that was just a little curveball there. And then got a few more on the back. So this is the derivative. Okay, now both of these are supposed to be graph and calculus problems. I mean, if you just look at the answers, you should probably get that feeling because there's no way you're going to get answers like that by hand. So these, all the problems on the back are graph and calculus problems. So this is the derivative. We have another value. So this is fundamental theorem of calculus part 1. Because if you integrate g prime of x dx, you should get g. Use the known and the desired values. I go smallest to biggest. And there you go, fundamental theorem of calculus part 1. Now we're looking for g3. So g3 equals g2 plus the integral 2 to 3 of g prime of x dx. And then I'm going to replace g of g2 with the value of 3 plus the integral 2 to 3 of, you want to show these setups, g prime is x natural log of x squared, which I don't know if we would actually be able to integrate by hand. But the good news is you have a calculator. So we'll just put all this in to our calculator. So 3 plus math 9 x parentheses natural log of x close close squared comma x comma 2 comma 3 and we get 5.162 or 5.163. So a little fundamental theorem of calculus part 1 with the calculator. Next one says let g of x be the antiderivative of this. So what does that mean? If g is the antiderivative of this, that means if you integrate f of x, you get g of x. G is the antiderivative of this, which also means that this is the derivative of g, right? So this is another, I think, fundamental theorem of calculus part 1 type of problem. If we integrate g prime of x dx, we're going to get g. We're going to go from 3 to 6. And then we know that we're looking for g of 6. So g of 6 equals g of 3 plus 3 to 6, g prime of x dx. So g of 6 equals g of 3 is 0 plus 3 to 6 of e to the x over x squared dx. And I'm going to plug that into my calculator. Math 9, e to the x divided by x squared, comma x, comma 3, comma 6. And we're going to get 15.512 or 15.513. There you go. Pretty nice. All right. Number 7, the present price of a new car is this. The price of a new car is changing at a rate. So this is P prime. We'll say P for price. P prime, this is the derivative they've given you. How much will a new car cost 5 years from now? So we have P0 equals 14,500, and we want to know P5. So this is another fundamental theorem of calculus part 1 problem. If we integrate P prime, we get P. If we go from 0 to 5, we get P5 minus P0. We want to know P5, so P5 equals P0 plus the integral 0 to 5 of P prime t dt. So P5 equals 14,500 plus integral 0 to 5 of 120 plus 180 square root of t dt. So P5 equals plus math 9, 120 plus 180 square root of x, comma 0, comma 5. And we get 16441.640 or 16441.641. Looks like we're just picking the closest dollar amount. And so I think we're going to go with C. All right, that's it. Hopefully you're good at fundamental theorem of calculus part 1 and 2 again.